Okay, so 7.2 says show that the distance between the strange objects at point B and the control room at point C is given by BC is equals to H root of 25 minus 24 cos squared x. So we are trying to show that this is true. So to prove that BC is equal to H root of 25 minus 24 cos square x. This is all within the root. So this is what we are trying to show. And in order to do that, I've included our answer from the previous question, of which I will simplify. Because sine 30 gives us a half, this is h over half, which is basically 2h. So this is something we can include on to our diagram. Now, one side is 2h, the other side is 3h. The angle between these two sides is 2x, and we are trying to find an expression for BC, which is this side. And in order to do this, what we have are two sides and one angle. So we can work with our cos rule. We can't work with sine rule because that will need us to know another angle, since we are solving for a side. So two sides and one angle, especially in this case where you have the two sides sandwiching the angle or creating that angle over here. So in terms of the cos rule, this would be our A, this would be our B and C. B and C can be interchanged, and then this will be our angle A. So if I were to write down the formula in terms of the sides given, what we're looking for is BC. So BC squared is equals to AB squared plus AC squared minus 2BC cos of, in this case, BAC, that angle in there. Then we can make some substitutions. AB just calculated to 2h, square that. AC given as 3h, square that, minus 2. This B and C is supposed to be AB and AC, like that. So 2 times AB is 2h and AC is 3h. And then we multiply by cos of 2x, since that's the size that is given. Then we continue trying to simplify this. So 2h squared plus 3h squared, that's 4h squared plus 9h squared. That gives us 13h squared minus 2 times 3 is 6h times 2, that gives us minus 12, or times minus 2 gives us minus 12h. And then we still have our cos 2x over here. Then what you want to do is you have cos 2x over here. This is a double angle, but we can see here there are no double angles. We only have cos square x, so we're going to have to make an operation that converts this to cos square x. So there's an identity for that. That would be 2 cos square x minus 1. So I'll just highlight this as that. That's an identity. And we can continue. 13h squared, this is supposed to be 12h squared, since h times h gives us h squared. And yeah, at this point we can multiply in. That'll give us minus 12h squared multiplied by 2. So minus 12 times 2, that's minus 24. So that's minus 24h squared cos square x. Gets a little messy. Plus, since minus times minus gives us positive, 12h squared, like that. Then these ones are like terms. Put them on one side, we can have 25h squared minus 24 h squared cos square x, and then you can see it's starting to come together. The last thing we have to do is factor out h squared to get 25 minus 24 cos square x. Then we can bring down this BC that we have been neglecting. Take the square root of both sides. Here the square root will operate on these separately, giving us BC is equals to the square root of h squared will give us h, and then the rest of that expression can't be separated on the minus, so we keep it as 25 minus 24 cos square x, like that. And we see we've proved that BC is equals to that.